Hey guys, in this video, we're going to talk about another factor of climate, which is the relationship between land and water. So, remember that we talked about specific heat in the past, and specific heat is the amount of energy needed for a substance to change temperature. Water has a higher specific heat than sand, and that's why water needs more energy to change temperature. Water changes temperature much slower than sand or land in general. Land heats up much quickly and even cools down way quicker than water does. And remember, we talked about land breeze and sea breeze, right? So during the daytime, when the sun is out, the land heats up faster than water, so the land is warmer and the ocean is cooler. At nighttime, when there's no sun out, the land cools down faster than water, so that's why the land is cooler and the ocean is warmer. But what if we wanted to compare areas or the climate of areas that are near large bodies of water versus areas that are not really near bodies of water at all? We need to learn the two vocabulary words. One is coastal. Coastal regions are regions that are near bodies of water, such as lakes or oceans. It's by the coast. And inland regions are farther inland, more near the land, away from water. And those areas are away from bodies of water. They're not really influenced by oceans and lakes near them. Okay, so let's look at a coastal region, a place near water. What would the climate be like here? Remember, when it's summertime, the sun is out and the ocean has a high specific heat, right? So the ocean heats up and cools down very slowly, and the land next to the ocean, yes, the land will heat up and cool down way faster than the ocean. But comparing a coastal land in a coastal region near water versus land that's not near water, the land near the water will act almost kind of like the water as well. The land will change temperature or heat up and cool down comparatively slowly when we compare it to places or land that's not near water. So notice, since this area is near water, near the ocean, it heats up and cools down relatively slower near oceans compared to inland regions, right? And in inland regions where places that aren't really surrounded by water, they don't have any influence from the water nearby. So those places will actually heat up much faster and also cool down much faster than places or land that are near oceans. So coastal regions, the climate of coastal regions are very stable. It doesn't get too hot. It also doesn't get too cold because they're near water. But inland regions that are much farther from water, such as deserts, those areas will heat up and cool down very fast because there's no influence from the ocean nearby. So let's look at this. In this map we have two places in the United States, Omaha and Eureka. Notice that Eureka is near the water, right? Eureka is a coastal region, and Omaha is farther away from the water, much more inland. Omaha is an inland region. If we look at the average monthly temperatures of Eureka and Omaha, let's start with Eureka. Notice that Eureka's temperatures and these are the months, by the way: December, January, February, March, and so on. Eureka's temperatures go really low in January and December, and then really high in June and July. Okay. Sorry, I'm talking about Omaha. Let's refresh that. Let's restart that. So in Omaha, the place that's not near water, my temperature goes really low in January and December, and then really high in June and July, because Omaha is not influenced by the water, right? That's why it changes temperature so quickly. It goes really high and then really low. We call this a high temperature range, meaning the difference between the highest and lower temperatures are really a lot. My high temperatures are really high, my low temperatures are really low. Now, Eureka, however, since it's near the water, it's influenced by the water, right? And water doesn't change temperature that fast. It doesn't heat up too much. It doesn't cool down too much, and that's why Eureka is also affected by that. So that notice that in Eureka, regardless of December, June, July, January, my temperature does go low, and it does go high, but not that much. We call this a low temperature range because Eureka's temperatures heat up and cool down much slower, right? The difference between the higher temperature and lower temperature is not much. So temperature range is the difference between highest and lowest temperatures. For Eureka, Eureka has a low or small temperature range because the difference between the high and low temperatures not that much. It's very stable. And versus Omaha, Omaha has a high temperature range, meaning there's a large difference between the high and low temperatures because it heats up and cools down much faster. So this is in your note packet. Go and write this down. Another factor for climate is land-water relationship. And cities near water actually have a smaller temperature range. The water influences it, so the temperature doesn't go too high or too low, kind of like Eureka here. And that's why the difference between the highest and lowest temperature isn't much. We call this a small temperature range or a low temperature range. If a city temperatures go really high and then really low, we would call that a higher temperature range. There's a big difference between the high and low temperatures. So, pause this video and try number 14. The arrows on the map below show the prevailing winds at a mid latitude coastal city. Coastal means near water, right? And so, this city most likely has a climate that is. The correct answer is C. Humid with a small difference between highest and lowest yearly temperatures. So, how do I know it's humid? Well, because the arrows are pointing from the ocean to land, right? The wind is blowing from the ocean to the land. Just like we've seen when we were talking about monsoons, when winds do that, it's also taking moisture from the ocean and putting it into the land, right? So, it must be humid. Remember, arid means dry. Humid means there's moisture. And it has a small difference between highest and lowest yearly temperatures because it's near the water. The water heats up and cools down slower, and so does the land next to it compared to inland places, right? The land will still heat up and cool down faster than the ocean, but right now we're comparing land that's next to the ocean versus land that's not. And remember, highest and lowest yearly temperatures, if we have a small difference, that means we have a low temperature range, kind of like this. Try number 15, pause this video. Riverhead, New York has a smaller average daily temperature range than Elmira, New York, because Riverhead is located at. The correct answer is A, near a large body of water. You might recognize Riverhead and Elmira. These are places in New York State, and you can find it in your reference table, page 3. Here's Riverhead, right here, down here, and here's Elmira. Notice that Elmira is next to Pennsylvania. There's no water here. But Riverhead is next to the Long Island Sound. This is actually a lot of surrounded by water, right? And it's also close to the Atlantic Ocean. That's why, since Riverhead is near a large body of water, it will have a smaller average daily temperature range. The temperature won't go too high or too low. The water will stabilize it. But Elmira is more inland, it's not coastal, and there's no water around it, so its temperature will change drastically. It will have a high temperature range. The temperatures will go really high and then really low. Try number 16, pause this video. Base your answers to the question on the graphs below and on your knowledge of Earth science. The climate graphs represent data for 3 different locations in North America. Line graphs show the average monthly air temperatures in degrees Fahrenheit. Bar graphs show the average monthly precipitation in inches. The circled dot indicates each location on the map. State one reason why the annual temperature range of Calgary, Canada is greater than the annual temperature range in Sitka, Alaska. Well, let's see. These are showing our temperature ranges, right? Remember, the circle dot indicates the location, right? So Sitka, Alaska is right here. Canada is right here, and then Mexico is right here. Okay, and this is showing the month, the x-axis, and the y-axis is showing the air temperature within those months. Notice that Sitka, Alaska's temperature goes high and then low, but Calgary, Canada's temperatures go really high and then really low. And then in Mexico, it doesn't go that high and as high and as low, and the temperature change isn't as drastic as Canada, is what I mean. So why say one reason why the annual temperature range of Canada is greater than the annual temperature range in Sitka. Remember, the annual temperature range is the difference between how high the temperature is getting versus how low the temperature is getting. Canada has a higher temperature range because the temperature between the highest and lowest temperatures is huge, right? But compared to Alaska, at least. And you can pick any of these reasons. So Calgary, Canada is surrounded by land, which has a lower specific heat than water. Notice that this is Alaska, this is Canada, and Alaska is closer to the water, right? And that's why the temperature is not changing as much. But Canada is a little more inland. That's why the temperature is changing so drastically. You could also say Sitka is near a large body of water and has a higher specific heat than land materials. You could say the large body of water near Sitka moderates the temperature. You could say Calgary has a continental climate while Sitka has a maritime climate. You could also say Calgary is further inland. That's why the temperature is drastically changing. In the next video, we'll talk about mountain barriers and how they relate to climate.